Hello everyone, welcome back to our channel. Let's go to the next name reaction, Baeyer-Villiger Oxidation. The name itself indicates oxidation. It means that what? We are doing oxidation phenomena in this particular equation. See the statement. Oxidation of ketones to esters with paracids, commonly called as Baeyer-Villiger oxidation. This is the what? Statement. So, Baeyer-Villiger oxidation is used for the conversion of ketones into corresponding esters by treatment with paracids. We all know that the paracids are represented with RC double bond OH. Here we are having a linkage called as peroxy linkage. The simple compound we all are familiar with what? H2O2, hydrogen peroxide. How can we represent this one? H oxygen, oxygen and H. Here what happens? One of the hydrogen is replaced with acyl group. Then that is commonly called as paracid. Already we know that acids are easily giving the protons. These are also acids. These can also give H plus ions. Right? Let us see the general equation. The general formula of ketone is RC double bond OR is going to treated with RC double bond OOH. Represent this one will be R dash. It can create a compound called as RC double bond OR. If you see this particular equation, this is the ketone. Simply we have introduced what? Oxygen atom or not. The oxidation phenomena is commonly called as oxidation means addition of oxygen or removal of hydrogens. Here we are observing what? Addition of oxygen or not. That's why this equation is commonly called as oxidation 1. How this transformation takes place? Let us see the mechanism. Mechanism is very simple. The first reactant is ketone. The ketone is going to treat it with what? Paracids. Oxygen, oxygen, H. We all know that the paracid produces what? H plus ions or not. That's why how can we represent this one? RCOO minus and H plus. Initially what happens? Oxygen having the lone pair of electrons. These lone pair of electrons are donated to H plus ions. It can produce as RC double bond OH. Oxygen donated its lone pair electron, that's why it is going to have positive charge, and R plus R dash C double bond O, oxygen, oxygen, negative charge. Here oxygen is having positive charge, that's why it wants electrons are not. These pi bonding electrons move towards the oxygen. to neutralize the positive charge. Because of that reason, what happens? This carbonyl carbon is going to have positive charge or not? This negative charge approaches this particular carbonyl. That's why what will happen? R single bond COH, oxygen, oxygen, C double bond O, R dash. Here it is R. This is one intermediate in the mechanism. This intermediate is subjected to decomposition or destruction. This point is very important. We need to have a focus on the particular intermediate. Here see what happens. These single bonding electrons are forming a pi bond with the carbon. Thereby what happens? At the carbon, valency is increasing or not? So valency increasing means what? We need to remove a particular bond. Thereby valency will be satisfied or not? Because of that reason what happens? Here one of the R group is removed in the form of R minus. The R minus is going to shift from the carbon to the attached oxygen. Thereby what happens? Here valency of oxygen is changed or not? In order to satisfy its valency, these single bonding electrons move towards the oxygen. So finally what will be removed? O minus C double bond O R dash. This one will be removed. Okay. Here H plus is removing or not? This H plus ion approaches to what? This O minus. Simply how can we write? R dash C double bond O OH is removed. Then R single bond C double bond O OR. This is the ester or not? In this way, we can convert the ketones into the corresponding esters. This intermediate is very important during the mechanism. The name of this particular intermediate is Craigie intermediate. What is the name? Craigie intermediate. So in this way, we can transfer the ketones to esters. Here we have some of the important points we need to remember. The first one, the Baeyer-Villiger oxidation is the acid catalyzed oxidation reaction. If you see the mechanism, initially H plus ion is attached to the ketonic group or not. That's why the people are saying it is a acid catalyzed oxidation phenomena. The second one is, during the mechanism we are observing what? The migration of R group from the carbon to oxygen. Migration of R group is possible. We know that the R group may be electron releasing group or it may be electron withdrawing. If we have different groups at the particular reactive center, what kind of particular R group will be migrated? That is very much important. As far as the examinations are concerned, the questions will be coming from this particular migratory aptitude of the R group. So let us see the migratory aptitude of different R groups. It can be written in this way. The first one is tertiary carbon. Simply we can say tertiary alkyl group. Second one, cyclohexyl. Cyclohexyl equivalent to secondary alkyl equivalent to phenyl equivalent to benzyl. Next, cyclopropyl. Next, primary alkyl, finally methyl. This is the migratory aptitude of the R group. It means that what? If you are having two groups, tertiary alkyl group and cyclohexyl group, which group will be migrated? The tertiary alkyl group will be migrated. If you have either secondary alkyl, phenyl, benzyl or cyclohexyl along with these, what will happen? These groups will be migrated. Right? This is one important point. Suppose the R group may be phenyl group. It means that what? It may be a phenyl group. This particular phenyl group may have the substitution. It may be a electron releasing group or it may be a electron withdrawing group. If you see the migratory aptitude, that will be like this. CH3, phenyl, chloro and nitro. It means that what? If a ketone is containing both methoxy substituted and methyl substituted, which one will be migrated? Methoxy group will be migrated first. Suppose if you are in competition with phenyl and chloro substituted one, what will happen? The phenyl group will be migrated. If you see this particular Craigie intermediate, this particular R group is migrated towards the oxygen or not. It means that what? Along with that particular R group, we need to put the oxygen simply. Right? Let us see the applications of this particular Baeyer-Villiger oxidation. Applications. The first application, CH3 C double bond O cyclopropyl. This is treated with MCPBA in DCM. Already we know that the formula of peracid OH. This may be an electron releasing group or this may be an electron withdrawing group. Suppose if you take CH3C double bond O OH, it is the electron releasing group or not. Suppose if you take this kind of one, this is electron withdrawing group. Similarly, we can have if you remove the oxygen, that is benzoic acid. So in presence of oxygen, that is perbenzoic acid. In most of the cases, people are using this particular acid. This is metachloro perbenzoic acid. Metachloro perbenzoic acid. Why? Because this is very cheaper material, readily available in the market and highly stable at the room temperature. That's why what happens, we are using this metachloroperbenzoic acid in all these transformations. Simply, how can we identify the product in this case? If you see this one, in this particular ketone, we are having two groups. One is the methyl group, second one is the cyclopropyl group. See the migratory aptitude. First cyclopropyl, later methyl. That's why what happens? This cyclopropyl group will be migrated towards the oxygen. It means that what? The oxygen must be attached to the cyclopropyl. So let us see. CH3, C double bond O, oxygen, cyclopropyl. This is the final product. In this way, we can identify different kinds of the applications. Let us see some more applications for the easy understanding. The second example, cyclohexanone. It is a cyclic ketone or not? But this one is acyclic ketone. In case of acyclic ketone, what happens? You are getting with acyclic esters. But in case of cyclic ketones, you will come up with cyclic ester. Simply what happens under same conditions, in between these two carbons, we need to insert oxygen. This is the 6-membered ring. If you insert the one more oxygen from the peracid, that will become 7-membered ring or not? So you are coming up with what? 7-membered ring. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It will be 8. Seven members. The cyclic ester is commonly called as what? Lactone. If your ketone is cyclic in nature, you will come up with the lactones. The next example, CH3, C double bond O, pH. Under the same conditions, comparing with the methyl, the migratory aptitude of phenyl is major. That's why what happens? The phenyl group will be migrated towards the oxygen. So here we can insert oxygen. CH3, C double bond O, OPH. This is the compound. The next example, C double bond O, pH. In case of the bicyclic compounds, under the same conditions, here you need to remember a point that along with the pH, if you have a bridged bicyclic compound, this group will be migrated easily. That's why the oxygen is going to be inserted at this carbon. So we are going to have the compound with oxygen, C double bond O, pH. Another example, suppose if you have ketone in this way, CH3. Already we know that comparing with the simple phenyl, the substitute electron releasing substituted phenyl group having the more capacity to migrate. That's why what happens, this group is going to migrate towards the oxygen. That's why simply what should we do? We need to insert an oxygen at this position. So you will come up with what? Phenyl, C double bond O, so in this way you need to remember the migratory aptitude of the particular alkyl and aryl substituted groups. So according to Baeyer-Villiger oxidation, the ketones are converted into what? The corresponding esters by using paracids. This is the statement of Baeyer-Villiger oxidation. Suppose in place of the ketone, if I take aldehyde, can I get ester by using the paracid? Is it possible? Certainly not. Aldehydes cannot give esters by treatment with paracids. Why? Because the aldehydes are oxidized to carboxylic acids by using the paracids. So aldehydes cannot produce esters by using the paracids. Why? Because the oxidation phenomena takes place. That's why we are observing the carboxylic acids. Suppose if you treat the aldehyde with peroxide in presence of base, what the people have observed, the corresponding alcohol. Simply how can we represent? Conversion of CH to OH by treatment with hydrogen peroxide in presence of base. This reaction is commonly called as Dakin reaction. This reaction is commonly called as Dakin reaction. In Baeyer-Villiger oxidation, what happens? Ketones are converted into esters by treatment with the paracids. The same situation have been applied to the aldehydes also, but we could not get the esters. What happened? Aldehydes are subjected to oxidation to form the carboxylic acids. Right? In the latter stage, the people were used H2O2 in NaOH, and they have identified that the CHO group is directly converted into the corresponding OH. The reaction is commonly called as what? Dakin reaction. The same reaction can also be performed to the ketone with H2O2 and NaOH. Here they are getting ester. This is the magic. Ketones are converted into esters by treatment with the paracids as well as peroxide in base. But in case of aldehydes, we are not getting. In case of aldehydes, we are getting alcohols if you treat it with H2O2 in NaOH. That is commonly called as what? Dakin reaction. It's very, very simple reaction. So let us see this transformation, how the aldehydes are converted into the corresponding alcohols. OH, CHO is going to treated with H2O2 in NaOH. So already we know that H oxygen H is going to treated with what? Base or not? So base can remove this proton, can generate HOO minus. The removal of H plus takes place. This anion is going to attack the carbonyl carbon. Let's see. OH, C double bond OH treated with O minus OH. So it is attacking oxygen, so it can form single bond OH, single bond O minus oxygen and OH. Okay. Here what happens? The oxygen minus can form a pi bond. Thereby you will come up with C double bond O. Here what happens? this complete group is subjected to migration at oxygen. Thereby what happens? OH is removed in the form of OH minus. So we will come up with this kind of situation. See this one. This is C double bond O. 1, 2, 3. 3 bonds means here we are having what? Hydrogen or not? So we have removed this particular group. So we have removed means we are having what? C double bond OH. This is connected to oxygen. Now this particular group is transferred to this oxygen or not? So here we are having the complete group and having OH. So simply what we have observed, in between this carbon and this carbon we have introduced an oxygen. See this? This is the oxygen. If this one is subjected to hydrolysis, what will happen? H plus and OH minus. So HCOOH, formic acid will be removed and we will have OH. Simply see this one. The aldehyde is converted into what? The corresponding OH or not? This reaction is commonly called as Dakin reaction. It's a very important reaction. Simply you need to remember that if you want to convert the aldehyde group into the corresponding OH, directly use Dakin reaction. Okay. So this is all about Baeyer-Villiger oxidation followed by Dakin reaction.